This is a question on ABC factoring. It's a really hard application of that. Now, ABC factoring is something that you really do need to know. Just to give you a little context and an example of how it's done, let's say we had BC factoring. BC factoring would be an example like x squared plus 9x plus 20. Now, a quadratic is in the format of ax squared plus bx plus c. So here the a is 1, the b is 9, the c is 20. So when the a is the invisible number 1, and we're only really seeing the b and c terms, in this case 9 and 20, that's BC factoring. And for BC factoring, you need two numbers that add to b and multiply to c. So two numbers that add to 9 and multiply to 20. And those two numbers are 4 and 5. So once you find them in nice, easy BC factoring, you're done. X plus 4, x plus 5. Now, ABC factoring is much more complicated. For ABC factoring, you need two numbers that add to b, just like before, and multiply to AC. So our two numbers, let's just say if we had an example, y equals 3x squared minus 10x minus 8. In this situation, we would need two numbers that add to negative 10 and multiply to negative 24. So in this example, what two numbers add to negative 10 and multiply to negative 24? If you kind of go down the list and think about it a little bit, the numbers would be negative 12 and 2. So when we find our numbers, negative 12 and positive 2, then what we do is split the middle term into those two numbers. The order doesn't matter. Minus 12x plus 2x. So right now we have 3x squared minus 12x plus 2x minus 8. The next step in ABC factoring is you factor by grouping. So you take the first two terms and the second two terms, and you take a GCF for each. The greatest common factor, the GCF, for 3x squared and minus 12x is 3x. And if I factor out 3x from both of these terms, I'm left with x minus 4. If you're having trouble with GCF factoring, you can look that up. And at some point really soon, we hope to have our own modules on that as well. Now we need the GCF for the next two, 2x and negative 8. They both have a factor of 2. And if we factor out the 2, it'll leave us with x minus 4. Now these two parentheses must match, or else you did something wrong and you need to backtrack and figure out what you did. But if they do match, you take out the x minus 4 and it leaves you with 3x plus 2. So this is how you do ABC factoring. And if you're a student wanting a top score on the SAT or the ACT, you need to be able to know how to do this. So that's the mechanics of ABC factoring. Now we're going to apply that to this question here. So let's just go ahead and put a little marking around this so that people who are looking at the written explanation know that this is just a little example. So we have our example 1 and we have our example 2. Okay, but getting back to this question, if we're factoring this, and if we're trying to use ABC factoring, even though we really can't because we're missing the B, but you need the two numbers that add to B and multiply to AC. And once again, that's our ABC factoring method. And the B in this situation is the letter B. This is your A, that's your B, that's your C. So your A and C would be 4 times negative 45, which would be negative 180. So now we can think of all of the pairs of factors of 180. And it's a really long list. 180 divides by 1, of course. It divides by 2. It divides by 3. It divides by 4. It divides by 5. I believe that's 5 times 36. Six, 9, and it also divides by 10. And not to mention 12. So 180 has a ton of factors. Now, what you really have to do here is you have to just kind of pick these different combinations and see which ones work out. For instance, if I had 2 times 90, if 2 and 90 were our factors, notice how in this situation, when we realized that it was negative 12 and 2, we split the middle term into negative 12x and 2x. So let's just say we were taking 2 and 90 and we split the middle term of our ABC into 2 and 90. First of all, the 90 would have to be positive and the 2 would be negative to give us that plus sign right there. So let's say 4x squared plus 90x minus 2x minus 45. So what did we do? We kept the 4x squared, we kept the minus 45. We're imagining what if this thing factored with a 2 and a 90. And so we're splitting the middle term into 90 and negative 2, 90x and negative 2x, just to see what happens. That's what we're doing right now. So now, does 90 divide by 4? That'll be critical to know. It does not. Okay, so now the next thing we'd have to do is the GCF of the first two and the GCF of the second two. And so 2x is the GCF. That leaves you with x plus 45 minus 2 x plus 45. And so that'll factor to x plus 45 times 2x plus 45. Okay, and I'm seeing I did something wrong. Backtrack a sec. If the factor were 2x, it leaves you with 2x plus 45. There we go. Much better. And here we can take out negative 1, and that leaves you with 2x plus 45. So I think I kind of like explained that by accident, that if these two things are not matching up, you know you did something wrong and you can backtrack. And there's always some trial and error in these things. So now we would take out the 2x plus 45, and it would leave us with 2x minus 1. And now we know that 2 and 90 is not a combination that would work here. The reason is because they said in this question that when it factored, you were going to have a coefficient in front of one of the x's, but you were not going to have a coefficient in front of the other. So hx plus k and x plus j. So in other words, you can't have 2x plus 45 and 2x minus 1. That means that there would have to be the same coefficient in front of both x's. And that's not how it worked out. So we just found out that 2 and 90 is not a possible combination for this situation. So let's try another one. Let's try the 5 and the 36 now. So if 5 and 36 were the factors, we'd be still keeping the 4x squared, keeping the minus 45, but we'd be breaking the middle term into 5x and 36x, with the 36x being positive. And that's because when you FOIL these out, first, outer, inner, last, let me just show that. So we would have 4x squared plus 36x minus 5x minus 45. So we kept the first and the last terms, and we split the middle one as 36 and negative 5. Now, this has to be the combination because when you add these up, you needed a positive term here and to match the positive sign right there. So that's the reason why we made the 36 the positive and the 5 the negative. So now we would need our GCF, 4x, that leaves you with x plus 9. The GCF here could be negative 5. That leaves you with x plus 9. Now, by the way, if we took out a 5 as a GCF, it would leave us with negative x minus 9, and then the two parentheses wouldn't match, and we would know we did it wrong. But yeah, so we took out 4x, x plus 9, minus 5, x plus 9. And when you take out the x plus 9s, it leaves you with 4x minus 5. Now, if you're really watching closely, you'd know that I probably would have written the x plus 9 first, because the one that you take out is the one you generally write first. But here I wrote it in the other order because I already know we need the hx plus k. So this one did work out because we had 4x minus 5. That minus sign is okay, by the way. I'll explain why in a sec. And x plus 9. So we had it in the format of a number in front of the x here, but no number other than the invisible number 1 in front of the x there. So in this format, we can say what our variables are. We can say that h must equal 4 right there. We can say k equals -5. And that's okay because they didn't tell us that these letters had to be positive. They just said integers. So that actually means that minuses are kind of okay, even though they're not preferable. And j is 9. And there is one more letter that we need to kind of solve here. And that is b. What is b going to be? And b is the middle term. When we were at this stage here, if we combine the 36x minus 5x, we would have had 31x. And that means that b, the thing in front of the x, is 31. So now we're trying the different answers. Answer choice A would have given us b over h, which is 31 over 4. So not an integer. We're looking for it to be an integer. Answer choice B is going to give us b over k. So 31 over k, which is -5. Also not an integer. C, 45 over h. So 45 over, and what is our h? 4. Also not an integer. And last but not least, D is going to give us 45 over k, which is -5. And that worked out to -9, and that is an integer. And that's why our answer is D.